Okay, so we would like to explain the Green-Stokes formula and show how it can be used in order to compute the vector line integral along the boundary of a triangle. So in any case, what we have is an oriented surface, and we have chosen a normal vector, and the boundary is oriented of this surface is oriented in a compatible way, which means that if you stand in the direction of the normal vector and face the direction in which you traverse the boundary, then the vector field is on your left hand. So if this is the case and we have a vector field which is defined on the surface, then its vector line integral on the boundary under this orientation is the same thing as the vector surface integral of its curl on the surface patch where that is oriented using the normal that we just mentioned. So first of all, what is the curl? The curl, formally speaking, for a vector field is the gradient operator crossed with a vector field, which means that you're going to take the cross product of the gradient operator is thought of as the derivatives with respect to x, y, and z. And let's say that f is PQR. Then this is going to be, in a formal way, ijk. Then we have on the second row the differential operators. Multiplication by them is differentiation with respect to the corresponding variable, partial differentiation. So if we delete first row and first column, we will have r sub y minus q sub z. If we delete the first row and the second column, we will have r sub x minus p sub z, actually with a negative sign in front. And finally, if we delete the first row and the third column, then we're going to get partial of q with respect to x minus partial of p with respect to y, which if you notice here, that's precisely the expression that appears in Green's theorem. So in some sense, the expression in Green's theorem can be thought of as a curl in 2 dimensions. So, okay, now let's go back to our problem. And we have this triangle, a very simple triangle. So here's the point 1, 0, 0. This is the point 0, 1, 0. This is the point 0, 0, 1. This is the x-axis, this is the y-axis, this is the z-axis. And this triangle is oriented in this way, which means that the compatible orientation on the triangle is the one that points upward. Okay, so let's begin by finding the curl of the underlying vector field. What is the underlying vector field? So f of x, y, z is actually equal to x z squared comma y, which means that the curl of f is the cross product of the gradient operator with f. Let's write down the determinant that we gave a moment ago. So partial with respect to x, partial with respect to y, partial with respect to z. Sometimes people call this del x, del y, del z. And then we have the vector field, x z squared y. And this is going to be what? Delete first row, delete first column. You will have 1 minus 2z. delete the first row, delete the second column, we will have 0 minus 0. With a negative sign, of course, that's still 0. And delete the third row and the third column. I'm sorry, delete the first row and the third column. That will give us, again, 0. Okay, so here's our vector field. And we need to take, so the vector line integral that we wish to compute, according to Green-Stokes formula, is going to be equal to the vector surface integral over S of the curl of F. And what do we need to do now? We need the parameterization of this surface patch here. And that is really part of the plane x plus y plus z is equal to 1. It's the equation of the intercepts. And we can use the graph parameterization. What do I mean by this? You can always think of this as z being equal to 1 minus x minus y. So this plane is the graph of the function f of xy equals 1 minus x minus y. And to obtain the graph, we just juxtapose inputs u comma v with outputs 1 minus u minus v. And the question is, what is the domain of this parameterization? And the answer is, it's the projection of the triangle onto the xy plane. So in other words, to be more precise, here we will have that v is greater than or equal to 0, less than or equal to 1 minus u, and u is between 0 and 1. So it's the usual triangle that we encounter in many such problems defined by the line u plus v equals 1 in the UV plane. Okay, so we need the normal vector. So n of u sub v is going to be g sub u cross g sub v, which is 1, 0, negative 1 cross 0, 1, negative 1. So this is a very simple computation. It gives us a constant vector, which makes sense because we have a plane, and that means that everything is, the normal vector is constant and transfers in a parallel way from a point to another point. So we get 1, 1, 1. And of course, we have to ask whether this is compatible with the orientation that we have. If we look at the third coordinate, we see that it's positive. So this points upward, which means we're in good shape. Okay. So we need to compose, before we take the integral, we need to compose the curl that we have with the parameterization. So what this really means is, instead of having x, y, z, we should have u comma v comma 1 minus u minus v. And if we look at the expression for the curl, we see that it's 1 minus 2z. So z will be 1 minus u minus v. So this will be 1 minus 2, 1 minus u minus v. And then 0 and 0. And this is the same thing as minus 1 plus 2u plus 2v, 0, 0. Okay, so now we need to take the dot product of what we just found with the normal vector. After all, remember that that's what the expression for the vector surface integral dictates. So this will be 2u plus 2v minus 1, 0, 0, dot with 1, 1, 1. and this is equal to 2u plus 2v minus 1. And finally, that's our integrand, which means that we will have integral from 0 to 1 minus u dv, 0 to 1 du, and we have 2u plus 2v minus 1. What do we get here? We get the integral of 2uv plus v squared minus v from 0 to 1 minus u. So this is from 0 to 1, 2u times 1 minus u plus 1 minus u squared minus 1 minus u. That's what we get. Too many parentheses here. Sorry about this. And let's FOIL everything that we have inside. I hope I'm not making any numerical error here. If I do, then send me an email and I'll correct it. Plus 1 minus 2u plus u squared minus 1 plus u du. Let's see what kind of simplification we have here. We have u squared minus 2u squared, so minus u squared. 2u minus 2u cancel, and we have plus u, and then plus 1 minus 1 du from 0 to 1, and this will be minus u cubed over 3 plus u squared over 2 from 0 to 1, which gives you negative 1/3 plus 1/2, which is 1/6. And that's it. Okay, so as you can see, there's a lot of things to keep track of, but you need to practice those few things and become comfortable with this. Thanks for watching.